Hello everyone. Today this talk will be an introduction to the ChemLocator application from the ChemAxon portfolio. First we'll talk about the history and the purpose of the application, why it was born, what purposes it serves, and then we'll give you some ideas or hints how it does solve the problems and what kind of problems it can solve. Then go into a little bit deeper and look at what's under the hood. It's gonna be a little bit more technical, but don't be scared, it won't be very deep. And at the end there are some options for integrations with ChemLocator as we think could be useful for you as well. So let's start with the history. And it's a little bit misleading, I agree, because it shows SharePoint. However, ChemLocator is not a SharePoint extension. It does not work in SharePoint. It can connect to SharePoint, but ChemLocator is a standalone application with its own engines running under the hood. But the history starts with SharePoint because previously ChemAxon has tools in SharePoint extensions for capturing chemical data and also for searching chemical data. But after a while we discovered SharePoint is not the easiest to use by the clients. However, it's very advanced, then it's also very useful, but it's also very hard to use and maintain and operate. That's why we decided to move away from SharePoint and providing the popular feature of SharePoint, which was the chemical searching, in a standalone application. And that is how ChemLocator born. What's the purpose? So look at this diagram here. As you could see from it, it's kind of linear today. However, even if it stays linear, you will see how many new publications will be published every single year. So we will reach an amount very soon, if we haven't done it yet, where it will be very hard to digest everything manually. So you will need to automate, you will need something which automatically digests this new information for you, and you will only get insights and you will be able just to cherry pick or select small part of this information which is interesting. So this is one pane what really exists, and that's one target or one thing we can ease as we think with ChemLocator. But give you some overview what ChemLocator is itself. So the ChemLocator is a web-based search tool to find chemistry in unstructured data. This is the main purpose. However, it has different features, more features than that, but this was where we started, and that's still the main feature of ChemLocator. Unstructured data is maybe something which needs to be explained here. It has a Wikipedia definition which says that it's a predefined data, anything which has no predefined data model and not organized in a predefined manner, but in practice it means usually documents. It means usually documents like Word documents, PDFs, websites, whatever kind of documents. What we don't do is we don't store documents. That's why we are not a content management system, and that's why we don't duplicate the documents. And that's good from that point of view. We are not duplicating information and not contributing to the kind of mess which can happen in any company who handles documents. So the purpose of this application is to convert this unstructured data to structured, which we call data, insights, information. You can call however you feel comfortable, but the purpose is still the same. You would like to convert an unstructured data set to something which is searchable, which is stored in an organized way, usually in a database. And for that, We use all the ChemAxon naming technology we have under the hood. We are using free text indexing technology. And if it's not enough, because for instance, the document itself is a scanned PDF, there we use optical character recognition, which will help us to detect the text on the pictures, on the images, and that works very reliably. And we also use optical structure recognizer tools, which are not part of the ChemAxon portfolio, but we have good relationships, so out of the box we can use more than one structure recognizer tools, which can work with ChemLocator, and we do many other things like metadata, keyword extraction, so on, so on. So a little bit even deeper, what we exactly detect in documents. So we detect the documents which are, for instance, Office documents, like Word, Excel files. We can also detect Excel files with chemistry extensions, chemistry add-ins, like the JChem for Excel, or the Excelis or ChemDraw enhanced Excel files. We can detect, or we can read purely, let's say, chemical files as well. As we mentioned, we also recognize images, information on images. We have the naming inside, which provides you a nomenclature, so we will know the synonyms of the same chemical structures. As you could see here, there is a lot of synonyms listed for the same compound, same structure here. And we also know corporate or compound identifier detection, which means that in many cases in your documents you don't repeat the drawing, you don't repeat the name. You have an internal ID and you will just repeat the internal ID in the documents, and that is something we can also detect and handle. And what questions can we answer with ChemLocator? Just some ideas really. So you can read too, but ChemLocator can be used for new target identification. It is sometimes used in drug repurposing project. It can help to find adverse effects, drug adverse effects, and also it can reveal some relationships between or in documents as well. But this is for the pharma sector. However, ChemLocator is used outside of pharma sector as well, like in agricultural projects, where it was part of the project management system as handling project management documentations. It can be used as a central UI, which hides the complexity from the end user, because in a company there could be many isolated knowledge islands in different divisions, for instance, and this could be also hidden behind a central user interface, which can be ChemLocator as well. And then from this user interface you can reach every single data set in the company. ChemLocator can be used for searching clinical trials as well, and also understanding ELN data, which mostly means that in ELN you can, in many ELN you can attach documents to experiments, for instance, and these attachments can be chemically searched as well. Just some ideas here. And the next one, how does it solve the problems? What problems exactly? So for instance, how it solves the problems, mostly through connectors. This means that ChemLocator, as I mentioned, not a content management tool, so we don't duplicate, we don't store the documents. However, we have connectors who can connect to different sources, data sources, and read the data from there. These are the connectors already implemented. As you could see, we can cover cloud drives, network documents, local documents, website, even Oracle database can be connected, and of course a SharePoint, as I mentioned. And if it is not enough and you have very special repository in your company, then since it's a modular system, we can also implement a connector to your dataset. And then, what is under the hood? What is the architecture behind This is gonna be a little bit more technical, but not so much. So I think it will be easy to follow. The whole thing starts with the indexing. As any kind of search engine like this one is doing the indexing, the pre-processing of the data, and just transforming the data into a way which is easily and must or can be searched later in a faster way. So right now here the indexing is the first step, just as well as in other engines. So first, when the client starts the indexing, then it means it connects to a REST API, and this REST API is part of a ChemLocator image system, which is we provide Docker images here, so everything can be hosted kind of platform independently, because even the application, the ChemLocator, is a platform independent application right now. So then the indexing started by the client, and the first step is the authentication and authorization. We can connect to LDAP, Active Directory, any kind of LDAP system, Active Directories, and once the call is authenticated and authorized, then the client, if they have access, they can start the indexing. The first step of the indexing is collecting the available documents in the data source. This is done by the crawler, and this crawler can use this. If you remember, we mentioned the connectors previously, can connect to these external repositories like the cloud drives or network drives, and then collecting the documents which are then passed to the indexing nodes and the indexing component. The indexing component is responsible to pick up the elements from that list one by one. It can be parallelized, of course, in real life to make it faster, to work it faster. But it's picked from the list, and then getting the document, reading the document from the source, which depends on the connector type, because obviously it's different to read from Google Drive than a local folder. And we apply the extractors. So that means the documents are passed to all extractors. These are the modules which are responsible to extract data or extract insights from the document content. And once these extractors are processed, all of them, then we store the structures and we store all the extracted information in the ChemLocator database. We have also a different engine which we call the free text engine, which is Elasticsearch at the moment, and all these free text indexing results are stored in Elasticsearch as well. So this is how it is working in a nutshell. I mean, the indexing is working in a nutshell. The other part of the application of the search, of course, which can happen after the indexing, this is using the same REST API under the hood, and this is working exactly the same way. We have the clients, which can be real customers, real users, it can be websites, it can be API integrators, so it can be a lot of things, because the REST API is available to all of them. And after the initiating or starting the query itself, the REST API will get this call and identify the caller, again using the external user repository to authenticate, authorize the application, the caller. And then if the caller is allowed to perform the query, then the query node will take over. They will do the chemical search in or PostgreSQL database, collect the document. In parallel, we run the free text search in the Elastic environment, and then when we have the hits, then we also do security trimming if it is needed. It can be switched off, but if it is needed, then we will always detect that a user has access to the documents in the hit list or not. And those documents the user doesn't have access to, they will be filtered out and they will not be part of the results sent back to the user. And once the security trimming happened, then we merge these hits and then send it back to the client. And last, we look into the integration options, because this is how usually the external applications are using ChemLocator. What types of usage is possible, and how integration can happen with ChemLocator with third-party applications. And we have two different use cases here. One is the kind of user or UI based usage of ChemLocator, and the other one is the API based application, where there is really only a data exchange and no visualization happen. For the UI based application or UI based interaction, we provide a UI for the clients, but this UI is also just connecting to the API, so everything which we made available this UI through this UI is available for the integrators as well. And if the UI is not used, then the external tools like the ELNs, the cloud applications, NIME, or any kind of integrator application can directly connect to the REST API and get the data, doing the indexing, doing the searching through an API interface, and only get back the data itself, not with visualization. And under the hood, of course, under the API, the same thing what we showed, what we have seen previously is happening, but at the end the result is sent back through the UI or as data to the integrator applications. So these are the possibilities, and of course in ELN systems usually the second applies, so they are directly connect to your API and getting the data from there. So you can integrate ChemLocator into an ELN system in a way that the clients don't even know the ChemLocator is running under the hood. They will only benefit from the features that what ChemLocator provides them. So thank you for your attention, and see you.